Welcome to the module for the full depth reclamation on Inspection and Quality Assurance Program. My name is Trenton Clark and I'm with the Virginia Asphalt Association. As we go into this module, I'd like to refer you back to the basic asphalt recycling manual put together by Federal Highway Administration and ARA. This is an excellent manual if you're new to FDR to look through to understand what the process is, but also some of the things you should be looking for. This is a general nationwide type manual. What I'm going to get into is the specifics of inspection and QA here in the state of Virginia. So what do I hope you get away or take away from this? Well, one, what's your responsibilities as an inspector? So if you're in this class and you're doing this and you're going to be on the inspection side, what are you looking for? We want to make sure as the contractor is doing the correct longitudinal joints, having the correct amount of overlap, so we have a nice, uniform, tight joint down the road, either between lanes or between directions. What are the specifications and inspection points for FDR? What are those pay items? And then we're going to briefly touch on the components of a quality assurance program. So, let's look at inspection. What are you looking for if you're out there? One, is that existing pavement being prepared properly? Well, remember, we're doing full depth reclamation, so what does that mean? How do you ensure it's prepared properly? We'll get into that, but remember, this whole process, as we've gone through the modules, is we're pulverizing the existing pavement and we're compacting it and putting it back to a new grade. So we're making sure that that's being done properly. We're making sure the correct equipment's being done, being laid out. It's in the specs. We'll cover that. If any new material is being delivered, it's within specs. For full depth reclamation, what we'll concentrate on is not the surfacing material, but if aggregate has to be added, that those aggregates are coming out, the water, the cement, the foamed asphalt, whatever it may be. Are we making sure that the material is prior to and after stabilization is within specifications? What are those? We'll go over those. Construction sequence and the QA program. So those are, as an inspector, the things that you need to be checking off through this entire process. True, this is the contractor's responsibility to follow, but as the inspector and as the owner's rep, you're making sure they're all going through the process. So let's first talk about what is construction inspection. If you're out there, whether you work for VDOT or a consultant for VDOT, you're the owner's rep. So you're out there, at the end of the day, this is being turned over to the owner, which is VDOT. So you're making sure that everything's being followed from your spec book to those special provisions. Are all the boxes being checked and are they being done properly? You're also making sure that the quality assurance program is being followed. It's a little different with full depth reclamation. This process is being developed, but you're making sure that as the contractor is paid for their work, that they're being paid for the work that they're supposed to do, as well as the material is within spec. Out in the field, we're really looking at density, and we'll cover that in a little bit. So let's do a spec practice. The best way to get most familiar with specifications for these types of work is to dive into the specs, the special provisions, and see if we can find the answers. So, what materials are we commonly using as stabilizing agents? What's the maximum particle size? The contractor's technical representative shall have how many years of experience? Who's responsible for developing that FDR mix design? And how are we paying for it? So let's take a moment, go through your specs, and let's see if you can find the answers to these, because these are 5 areas that you'll be presented out on a project. So let's take a few minutes and then we'll come back and we'll run through all 5. All right, so now that we've had some time to go through the specs, let's go through them. Make sure you're looking at that FDR special provision that's in your book. Open it up and we'll walk through each one of them. So what's the commonly utilized materials that we do in full depth reclamation? Well, if you look in that section 1, description, and section 2, materials, So you got two spots. The description, we talk about it, and then we get into the actual materials. We see it's typically hydraulic cement, lime, foamed asphalt, and asphalt emulsion. So when you look in that special provision, that's the type of materials that we're using. So when the contractor is doing their mix designs, unless it is spelled out in the contract, they're using one of these materials to stabilize the pavement. How about maximum particle size? So once you've pulverized and gone through and you go out and you grab a sample and you sieve it down, what's the maximum particle size we should see? Well, if you look in section 4.1 job mix formula, table 3 design ranges. So now you go on down through your spec and you find this section, you'll see it's 2 inches. So as that pulverizer goes through that reclaimer and you sieve it out, you shouldn't be finding any material bigger than 2 inches. Now a common question may be, what happens if I do? One of the things that has to be taken into consideration, back when we talked in Module 1 about doing soil borings, we're trying to assess the pavement design itself. If this is done prior to the project and we're finding material greater than 2 inches as part of that original pavement structure, there needs to be some adjustment already done in the contract documents to let the contractor know we have something larger than 2 inches. It could be large old macadam that was used to build this road originally. That may necessitate a special provision copied note. But if everything is less than 2 inches out there, the reclaimer is not going to break it down. It's not a crusher. It's not a screener. So everything should be 2 inches or less by spec. So again, that's just one of the things that's in there into your documents. Let's look at a few other things. Contractor's technical representative at the project site shall have how many years of experience? Remember we said by spec now you have to have a credential, you have to be an FDR technician. But for the contractor, especially if they're early on into this, they're going to have another technical representative on site for that trial section that has a minimum of 2 years experience. When's this necessary? To go out there, we have some issues. The department says, hey, you need to get a technical rep on site. If the contractor hasn't been doing this for multiple years, they may be bringing in an outside consultant or an outside manufacturer representative that has that 2 years to ensure that the whole process is being followed. Everything from the pulverization to the addition of water to the putting either the cement or into the foam, the asphalt, or the emulsion is being properly followed to make sure that the whole process is going to have a successful trial section. Who's responsible for the development of the FDR job mix formula? If we look in the special provision, we go to section 4.2, mix design submittal, and it says the contractor is responsible. Again, in the special provision, it reads this way. If you look through your contract document and there's a special provision copied note that provides the mix design to the contractor, then again, that overrides it. So you may have a unique project where the contract tells you what to do. You follow that because it overrides. But in most FDR projects, the contractor is responsible for obtaining the material, taking it back to the lab, making the mix designs that exceed the minimum set up in the contract. And last but not least, how do we specify and pay for FDR on a project? Section 10, measurement and payment. So in almost all specs or special provisions, the last section talks about measurement and payment. No different for this, where at the end of the document, measurement and payment is by depth in inches and payment by the square yard. So that contract says to do FDR to a depth of 8 inches. So as long as they're going 8 inches, then you calculate the number of square yards, you measure the number of square yards, and that's how they're paid. This is a close estimate in the contract documents, final payments based on actual measurement. So let's go back. I've mentioned a few things. I talked about them in Module 1. We have standard drawings For FDR projects, we're really up in this range with special provisions and special provision copied notes. Remember, we're talking about the FDR special provision, and if there's anything that overrides in that special provision, it'd be covered in your copied note. So remember, this always overrides everything below it. And if there's some general notes and plans, then it's treated just like a copy note and special provision. So again, it overrides. So you just have to read what's in there. These projects may or may not have plans, so understand what they say. So now we have that understanding and how we're going to do this. Let's talk about, as an inspector, what are the things that you're looking for? What are those inspection points? We have a mixed design, we're going to do a trial section. We need to look at the construction methods. Do the construction methods follow what's outlined in the spec? What is our acceptance testing? How do we ensure that the FDR process has worked properly? And making sure that it's the right type of weather. So we'll cover each one of these things, but as an inspector, you're making sure that all this is being done properly. So let's look at the trial sections. Why do we do them? Before we go full board out on a project, we want to make sure we have all of our ducks in a row, we have everything lined up, we have all the equipment, all the testing and acceptance is there to make sure that if we can do a trial section properly, then we can get into full production and have a high confidence of success. So we're replicating that full production. We're doing it about a week before we actually go to full production. Reason being, there's some lab tests we need to make sure that those materials pass, but we just need enough time, not start today, do a trial section, then start tomorrow, full production. We want to make sure everything's been evaluated before we go out and do miles and miles of road. That minimum is 2,500 feet, so it's roughly a half mile. That gives us plenty of room to go through, pulverize the pavement, go through and compact it, blade it, add our stabilizing agent, come back and repeat the process. So we want to make sure that we have enough length that we can actually replicate, and we're doing it a lane wide. We're not doing a half lane or 8 feet, but we're going to do the full lane width because we want to replicate again full production. And in full production, we're going to do the full lane. We're checking the contract depth with the stabilizing agent. So if the design and the contract said 9 inches, we're ensuring we went down 9 inches with the reclaimer, and we're going to consider this as a payment. So it's going to be a lot, 2,500 feet long, so we're going to pay for it. Also going to pay for it based on the results. So overall trial section, if it goes well, we move on to full production. If we have issues, again, the department can call in and say you need to bring in a expert, a technical rep to be present to see why we're not getting probably the necessary compaction. Once we get started, got to make sure the grass and the vegetation is not being reclaimed into the main line, because we don't want to have those organic materials mixed in with the new pavement structure. We want to make sure that the FDR process is going well. So are we doing the pre-cut? Are we compacting? So are we going through with that sheep's foot roller and getting the initial compaction? Are we grading it? So we're getting our cross slopes back, taking out some high points, filling in some low points. And this is all done prior to adding that stabilizing agent. So if you look through the FDR specification, it spells out this multi-step process. So it is a method-based specification as it's currently written. We want to make sure that the stabilizing agent's going in at the proper amount, so we're checking that. Could be weighing it up. We could be looking at a gauge on the side of the equipment, depending on what type of stabilizing agent is being used. Want to make sure we're in the job mix formula. Checking that water content, because again, we're adding water to a lot of these to moisten that material to help with compaction. When we get to that longitudinal joint, we got a minimum 4-inch overlap. So we go down the right lane, turn around, come down the left lane. Are we overlapping at the center line? Depending on the size of the reclaimer, if we have to make 2 passes where we have overlap, We just need to make sure that we have enough that we're not missing any material. And 4 inches is there to ensure that we don't miss anything. But we also don't want to put too much stabilizing agent there because we don't want to over strengthen it. And our transverse joints, are they vertical or are they clean? So at the end of the day, before we start off, do we have good joints to start back on to reclaim? So let's talk about initial depth checks. So as you can see in this diagram on this piece of equipment from working, that we have a hole on the bottom inches, on the top is in centimeters. As that housing is lowered, we can tell the depth on this ruler. So we're checking that. If it's set at 8 inches, we're checking it to make sure it's gone down 8 inches. We can also check it by going out, pulling some material away, and also measuring depth that way as well. But here's the initial depth check settings on this piece of equipment. We'll go through, so here's the reclaimer marching up the road. As you can see, this material fluffs up, because think about it, it's been compacted for years, decades, maybe 100 years. And then when we go through with this giant tiller, this reclaimer, now you've put air back into that system so it fluffs up. And here we are, we can see right behind it. So here's the tires of the reclaimer on this piece of equipment. And you can see all the particles in this picture. We come through, we do some light compaction. So here's a sheep's foot roller. We're going through, so now we've taken that fluffed up material and we're compacting it back down, giving it strength back. That moisture that we have added has helped giving us that compaction. So here we are on 2 different projects. Here we're getting ready to start the compaction. Here we've already made some passes. And now we come through with the motor grader. So we're doing that initial grading to get some slopes back. If we need some cross slope, we're putting it back in. Could take several passes of taking the material that's been compacted with that initial sheep's foot. Maybe we're clipping off, but we're moving material around, maybe moving material to the outside, depending on what's needed on that project. But now we're doing the initial grading. So remember, we're pulverizing, we're compacting, we're grading, and now we're coming back through and we're adding stabilizing agent. Here we're using an asphalt base. This is a foamed asphalt. So it's coming through a nurse truck that's going through this hose, goes into the reclaimer. From the reclaimer, it goes into the housing to mix it all in. So as the piece of equipment goes down the road, the material, the stabilizing agent's in the housing, and now it's mixing everything up again. Here's where we're adding cement. So you can see that here goes the distributor truck down the road. You can see the cement behind it. You can see it as it crosses that full width. Here's a road where we've done both directions. You see some excess material in the middle because we have gone through and already graded it. But now we're going through, we're adding cement, and now we've got it in place. What do we need to make sure of? One, how are we measuring the stabilizing agent? Is it a liquid material like an asphalt, or is it a dry material? Is it a slurry? All depends on what we're doing. If dry materials, we're checking it on the ground. So that picture of this cement truck, we've got, and I'll show a diagram here in a moment, of a burlap bag laid on the ground that we can pick up and weigh to check how much cement was actually applied. Both dry and wet material quantities are compared to calculated, so we know how far that we've went, we know how wide we've went, we know what the application rate is, how many gallons, how many pounds. We can calculate that. And we're making sure we're within 0.2% on the job mix. Again, we're not going to be spot on with no variation. There is tolerance during this production due to the equipment, how we have to go about doing it. It's not a perfect science, so we have a tolerance of 0.2%. And as long as we're within 0.2% of the job mix, everything should turn out fine. We're checking the water content. So there's a water meter on that reclaimer. So as that reclaimer is going up the road, it's connected to a water truck, and that water truck is putting water through a hose again into that housing at the proper percentage to make sure there's enough moisture to help when we go do compaction. We're doing some field moisture contents that stabilize material, making sure it's not too wet, making sure it's not too dry, and our spec limit is within 2% of optimum. Again, you're not going to be perfect because if you think about it, the moisture content of the material in the road itself varies along the length. So even if you've set it up at 5%, depending on how much of that moisture changes within that existing pavement, you're not varying it every few feet as the actual moisture content in the road changes. So you're setting it, you're applying it based on that moisture content, and now you're just making sure you're within 2%. Here we go. So you can see the truck's gone by. They're picking up the burlap bag. They're getting ready to weigh it, so they're grabbing the corners because they don't want any of the cement to fall off. And now they put all the cement in the bucket. They knew the weight of the bucket. Here it is sitting on some scales. We're having a digital readout. And now we've checked the application. So again, making sure that we're within 0.2% of the job mix formula. Once we verify that, now we make that second FDR pass. So the cement's been applied. If we're doing foaming, we're looking at the gauges on the actual equipment to make sure it's been applied properly in the right amount. Now we're coming through and you can see here's the cement laying on the surface, but if you look here behind the reclaimer, now it's already been mixed together. So if we're going down 8 inches, 10 inches, 6 inches, whatever it may be, we're mixing that full depth of that material. So we're making a pass, as you can tell by the width. We'll make a second pass right along that side to get everything mixed together. There's no more addition of another thing of cement. It's already in place. We're just reclaiming and putting it all back together. Okay, now that we've made the second FDR pass, we come back through, we bring the sheep's foot roller, you can see where it's been through. We start blading it back to get our final grade. We're going to compact it again. We'll also go through at this point with a steel drum roller to get the good surface. We're walking that sheep's foot until it comes what they call walking out of the material. So as you get compaction, it gets stiffer and stiffer. It starts coming up to the surface. We come with the roller behind it, making sure that the roller gives us a good surface, and we've completed the process. So what are the things, again, that you need to be checking for? Are we not putting any grass and vegetation into that FDR material? Are we looking at all the processes from beginning to end, starting at that trial section all the way through to the last part of that full production? Is our final grading and compacting correct? So are we putting some cross slope back on it if necessary, if that's what it's called for? Do we have the proper amount of density on this material before we start our next process, which would probably be either putting a couple lifts of asphalt on top of it or a surface treatment or a slurry surfacing to make that final pavement structure. So let's talk about the final grading and compacting. I showed you a slide of that, what it looks like, things we're looking for. Again, we're trying to get maximum density, and we'll talk about that in a spec in a moment, what maximum density is for these products. But we got to get the density for the performance of the pavement. Do we have the grading correct? Reason being, we need the water to drain, so there will be some cross slope on these sections. So are we checking to make sure that we have some cross slope built into these sections? And you'll notice that's controlled with the motor grader. It can also be controlled with multiple lifts of asphalt. If we're only putting a surface treatment or a slurry surfacing on it, it's even more imperative that there's a crown or a super in the road so the water that falls on it drains away. And once we're done with these, we might have to put some additional water on it to aid with the curing process and also to keep the moisture levels correct as it's gaining strength before we come back and start paving on top of it. So here's that final compaction. So that way down in the distance, you'll see here comes the motor grader, but that sheep's foot, you can see where we've been working it out, getting the compaction. once we've got it bladed off and come back and compacted it again, now you notice a nice texture all the way across. So now we've got the grades. A lot of times you might see them painted out on the project. There may be surveyors out there to ensure that we're hitting all of our marks. And now we do the final compaction after grading to ensure that that pavement's ready to accept that next lift. So here we are coming through at the end with a steel drum roller. So let's talk about those inspection points. So as we've gone through the process, what are the things as an inspector you need to be clear on? We talked about grass, the FDR, final grading, compacting. Now let's talk about the surfacing. If we're using a cement stabilizing agent, we got to keep it moist until we cover it with an asphalt-based surface. So whether asphalt concrete, slurry, or surface treatment, we're keeping that moisture in it. If it's bituminous, so if we're using an emulsified asphalt or a foamed asphalt, we got to check the moisture levels in that material. And as the moisture leaves, and we're down to 50% or less of optimum, now we'll go and we'll overlay it. Why do we wait? Because we want to make sure that moisture has time to escape. We don't want to trap it into the structure itself. So we have this per spec. And then once surfacing's on it, we can put the equipment, but we don't want to mar up the surface. So we don't want to go out there, do a lot of excessive turning, put a lot of equipment on there that destroys all the work that's just been done. So you're being very careful with that surface. And now we're ready. So on this project, we came back and we put 2 lifts of asphalt. We put 1 lift that was serving as a leveling and surfacing layer, and then the second lift was put on there for rod quality to give us also the final structural thickness. So now that we have built it, we've checked the stabilizing agent, we've checked depth, we've checked moisture, but we haven't checked density. Do we have the amount of density that is required to support the road and to meet spec? So when we talk about field compaction, well, we're using the nuclear gauge, we're using Virginia Test Method 10, which is in your books. We have the direct transmission approach with that nuclear gauge. So if you're familiar with nuclear gauge testing, that's actually driving a pin and then putting the rod from the gauge down into the material to check the compaction. And we got to make sure that gauge is working. So it's got to be calibrated. You should have a piece of paper that says that gauge was calibrated on this date and is working properly. We don't want to go out there with a gauge that's 3, 4, 5 years old. So we're going out with the right equipment. And this is being done by the contractor because the contractor is doing that acceptance testing. So we talk about field compaction. How big of an area do we do? Very similar to asphalt paving projects and other materials that we use in Virginia, we have lots. Within those lots, we do stratified random selection of test sites. What does that mean? Over a length of road and over the lane width, we're randomly selecting locations to actually do testing. We're not just picking and choosing, but we have a randomized process. That way we ensure that there's very little or no bias in the testing itself because we're not looking for the best areas or we're not looking for the worst areas. We got 2 tests per sublot. So what does that mean? Well, a lot can be 5 sublots, 5 1,000-foot sublots. In that 1,000 feet, we're going to test 2 random locations. So it can be anywhere from 0 to 999 feet that randomly selected that we're going to check the density to make sure it's right. Lots, depending on the project, can be as short as 3,000 or 3 sublots to up to 7,500. That really depends on the nature of the project. Sometimes the engineer will approve different lot sizes and sublot sizes, but typically it's 5,000 feet as a lot, 1,000-foot sublots. Also keep in mind Just like our asphalt base mixes where we don't test within 18 inches of a longitudinal joint. Same with FDR, so we're 1.5 feet into the mat. So if we're doing a 12-foot wide lane, you're coming in 1.5 feet from each side. And we're doing all of our acceptance testing there. New lot, the beginning of each new production shift, that just helps keep everything straight. Paperwork, we're not carrying them over from one day to the next. And all of our payment for these materials is per table 5. So table 5 says, let's look at our percent of the approved mix design. And if we're 97% or greater, we get 100% payment. So we look at what is our mix design approved density. And then out in the field, are we at 97, or are we at 96 to 97, or 95 to 96? Or are we less than 95%? And if so, it's 75% pay. Now keep in mind, if you have a sublot and we're not hitting the density, we're not hitting 100%, we may have an issue. We have that second sublot, we need to be stopping and figuring out what's going on. Do we have an issue with the compaction process? Do we have an issue with the stabilizing agent being added? Did the material drastically change and we're not really hitting back to the correct density? Those things need to be looked at before you do an entire lot to find out that you're not going to get 100% pay. Main inspection points, again, I just talked about 2 consecutive sublots with density of 97 requires immediate notification. We don't want to keep going down the road. So when we're less than 97, and we've got 2 sublots, we stop. All data has got to be given to the engineer at the end of the day, VDOT representative. So at the end of the day, all of our data, we're turning over a copy for the engineer to have as well as the contractor for payment determination purposes. So we've talked about compaction, we've talked about the lots, now let's talk about the depth checks. Again, now we're doing it after final compaction and prior to surfacing, so we're making sure that we have the right depth. If we called for 8 inches, we went 8. VTM 38 method B is the procedure that we're following, and that copy is provided in your book. Table 6 contains those tolerances, so based on the number of tests you take, if you're not at 8, how much off of 8 can you be and still be acceptable? We're not paying for excess material. So if you're putting in a lot of extra material, a lot of extra depth, we're not paying for it. And if it's deficient, so it's not thick enough, you didn't go deep enough, you have to come back through and take adjustments for that as well. And the contractor must furnish and place more material to correct the deficiency. So it's only 7 inches. How are you going to adjust for that deficient thickness? Here's table 6, so you can see, here's our plan depth. So if we're between 6 and 8 inches, 8 and 12 or greater than 12, and if we take 1 test all the way to 4 tests, the average, are we plus or minus 4/10? If we only take 1 test greater than 12, 1.2 inches. So again, we're going through for that lot, checking a couple locations. We can check more, we can check less, but are we within these tolerances of what was called for? And again, most of our projects are right around 8 inches. We have some as thin as 6, and we have some as thick as 12, but we don't do too many greater than 12 inches around the state. So we've talked about compaction, lots, depth checks. Let's look at gradation. So what needs to be looked at in terms of gradation? We're looking at that unstabilized material, so once the reclaimer's gone through, we're going out, we're doing a quick check, dry sieving it out. Do we have any material greater than 2 inches? We're doing it at least twice per day. Again, it's a check on the gradations. That'll be submitted as part of the job mix approval process of what they're shooting for. And everything's dry sieved. We don't want to add moisture to have clumping. We don't want to add the stabilizing agent. So this is all done once the reclaimer has gone through. So we're checking that. We're checking the dosage rates. So as I said earlier in this module, we're checking it, is it within 0.2% of the job mix? In VTM 141, it lays out that we're doing it twice per 1,000 feet. So we're ensuring as we're going down the road that that right amount of stabilizing agents being added. If not, you need to stop, take corrective actions. And if we get 2,000 feet or 4 tests within tolerance, so everything seems to be working, how we're distributing that cement or adding that foamed asphalt or that emulsified asphalt, we can reduce that to 1 test per 1,000 feet. But keep in mind, the engineer can do it. The contractor cannot unilaterally decide, I'm only going to test 1 per 1,000 instead of 2 per 1,000 because I'm hitting the tolerance. Get written approval by the engineer. Some other things to keep in mind, construction records. You're either following VDOT forms or AASHTO R18, and you got to give all the results to the engineer. So again, all this is laid out in the special revision of what you need to do, the step-by-step process. It's a very method-based spec, and it lays out to try to ensure success. A few other things, weather is critical. We can't do this when it is too cold. So we're looking at air and material temperatures. If we're doing a cement additive, it's 40. If we're foamed or emulsified, it's 50. Years of experience have shown these are the minimums. We've tried projects and we've played with the weather, and it hasn't been nearly successful. So in the specs, that's why we have 40 and 50. And we don't want any freezing weather. Why? Remember, we're adding some water to this. If there's still water trapped in that pavement that hasn't, or in that material that hasn't been released, hasn't evaporated, and it freezes, water, when it freezes, expands. The expands can break the bonds. It's in that stabilized layer, and it's detrimental. So when you're looking to do this process, and you're in the 40, 50 degree range, you need to be really looking at the next 2 days. Are we expected to see any freezing temps? And if so, we're not doing FDR. Last but not least, let's talk about the QA program. So like many technologies that are emerging, so is the quality assurance program. Overall, if you look in the Code of Federal Regulations, if you look in the VDOT Manual of Instructions and other things, it has different parts. We have quality control. So quality assurance is the overall program. Quality control is a piece of it performed by the contractor to make sure that their process and procedures are correct, they're being followed, that the material that they're producing is what was specified. But it's effort by the contractor. We have acceptance testing. Depending on the material, it's either done by the contractor or the owner, but we're trying to determine, is that product that's being provided acceptable or not? Then we have independent assurance. So we're going back through and we're really checking the quality control program. So it's being done by the owner, and it's making sure that the people, the processes, the procedures, and the equipment that's going in not only quality control, but the acceptance is actually working. We're not seeing, does it pass or fail? We're checking the process that goes into determining that acceptance determination. We do verification, sampling, and testing completely independent, again, by the owner. It's a check on the acceptance, but it's a check on the material to make sure it's within specifications for acceptance. So if the owner or the contractor says it's acceptable material, we do verification, sampling, and testing to make sure to verify that it is acceptance. And if we have a discrepancy, we have to find out why. Why did his test pass and his fail, or his pass and this one fails? We got to work that out. But the only way we can see if there's a possible problem is doing this VST, this verification, sampling, and testing. Contractors QC and acceptance many times are one and the same depending on the paving process. Could be they're just doing a lot more QC than actual acceptance. We got to do density testing twice a lot. QC, they might do it 5 times in a sublot. We're doing it in the lab on the gradations and conformance to Table 3, which is our job mix formula and the requirements. So we're doing this back in the lab for FDR. Out in the field, constantly doing gradation checks, density checks, moisture checks, and stabilizing agent checks. These are all things done in the field by the contractor to ensure everything is proper. So a lot of that goes into your quality control. The independent assurance, again, we talked about it. It's making sure that everything that's being used in the acceptance program is right. So the people, the processes. We do not have a documented procedure yet in the VDOT Manual of Instructions. As that's developed, it'll be added to the MOI, added to other documents. But we can do a comparison of VDOT and contractors' results when split samples are taken. So if we get 2 samples in the field and we're taking it back to the lab to do strength tests, what do the VDOT results and the contractor results say? If VDOT comes out and does their own independent testing of density with their own nuclear gauge that's been calibrated, they can either test in the same location, they can test elsewhere to make sure that, again, we have comparison. Our verification, sampling, and testing, again, normally correlates with what the contractor's done when VDOT comes behind, but again, there's no documented. What does that mean? In the future, that may very well look like VDOT goes out, they choose of this lot, as we do in asphalt, we're going to pick a sublot 3 out of 5 sublots, and in sublot 3, we're going to go in and do independent. So we'll drive our own pins, and we'll do our density testing to see, do we get passing, are we at 97% or higher? So again, that process is still being worked out, but it'll be very similar to what we do with other materials that VDOT uses on projects. So let's summarize. Know what's in the contract, know what the related specs are, know what the special provisions are, know those 4 primary areas for inspection. So if you're an inspector, what areas are you looking at? Make sure it's being done properly, whether it's starting at the very beginning and make sure there's no vegetation and grasses being mixed in, to the construction sequence, to the stabilizing. Make sure all that's being done properly. Know when corrective actions are needed. Are our stabilizing agents out? Are we having issues with density? And collect all the required data. So at the end of the day, you're getting the contractor's data records, whether it's electronically or in paper, to keep with your documents. And with that, if you got any questions or comments, talk to your moderator, talk to your facilitator, and good luck.